So electrolysis and electroplating is module 15, and if you guys remember from like the very first video I did on this with just a review on oxidation, module 15 is super short, and I mean it, like it's straight up a page. But yeah, so what module 15 deals with is electrolysis and electroplating, where electrolysis is a way of making a non-spontaneous reaction happen, or just something that's unfavorable, by adding electric charge to it. So we're just putting some electric energy into it and making it happen is what electrolysis is. And electroplating is essentially just the electrons being plated from this reaction. Which I know, yeah, it's funky, but essentially all you guys have to know is that this is going to be one long conversion that we're going to be dealing with in module 15. And the units that you need to know is Faraday's constant, which is equal to 9.647 coulombs per mole of electron. And then you need to know amperes, which is also known as amps, which is a coulomb per second. And then coulomb is just the SI unit of electric charge. Right. So then, as I said, we're going to have to do some example problems to kind of get you guys to remember, well, not to remember, but to understand how to do these. Why did I say remember? We haven't gone over this. You can't remember it. So essentially what we're going to do is determine the time needed at a current of 10.3 amps to generate 2.5 moles of sodium. Yeah, so that's the problem that we're going to be dealing with. Okay, I had to make sure that I was back on drawing. And essentially our reaction is 2 NaCl liquid yields 2 Na liquid plus Cl2 gas. So then first we're going to write the half reaction that we want to deal with, which is just essentially the sodium one, and it's just going to be that Na plus yields Na. So we're just breaking this apart down the middle, and we know that our Cl has a charge of -1 and this one of +1. So then we have to balance it, because this has an overall charge of 0 and this has an overall charge of +1. So then to get 1 to 0, we add 1 electron here, so that we have an overall charge of 0 on both sides. And that's all that we're going to be dealing with, because it's just asking for moles of sodium in the problem. Cool. So then we're going to start off figuring out, it's just a giant conversion, right? So we want to make 2.5 moles of sodium, and we need to figure out the time. So we start off with 2.5 moles of Na. Right, so like I said, this is going to be a very long conversion. So 2.5 moles of Na, and then per every 1 mole of sodium, we have 1 mole of electrons, because that's what we figured out here in our half reaction. And then per every 1 mole of electron, we have 1 Faraday, which is just going to be written with an F here, even though it's like a really pretty fancy F in general, but just an F. So then 1 Faraday is equal to 9.47 coulombs. So then coulombs, and then for every 1 coulomb. Okay, no, this is where we stop. My bad. Okay, yeah. So we stop at coulomb. So we do all this math, and essentially since all our denominators are 1, we just have to multiply the top part, and we should get 2.4 times 10 to the 5th coulombs. And then from that, we're going to figure out the seconds, because we have 10.3 amps, which is equal to 10.3 coulombs per second. And we're just going to turn this, well, per 1 second. And we're going to turn this into a proportion and do that we have 2.4 times 10 to the 5th coulombs over x seconds. So we just crisscross so that we have 2.4 times 10 to the 5th coulombs is equal to 10.3 coulombs, well, yeah, times x, and then we just divide by 10.3 so that we end up with 2.3 times 10 to the 4th seconds. And that's how long it takes for this particular problem to generate 2.5 moles of sodium. So yeah, like I said, it's just a really long conversion, and we'll do another problem because I do get that these conversions are kind of long. And if you don't know how to do them, it gets funky. So then determine the current that is required to produce 400 liters of hydrogen gas at standard temperatures. Okay, at standard temperature, which is 0 degrees Celsius, and at 1 atm from the electrolysis of water for 1 hour. Wait, why does my 1 look funky? Because there was an exclamation mark, my bad. So, okay, we're going to write down the equation that we need, which is going to be, 2 electrons plus H2O liquid yields H2 gas plus 2 OH minus aqueous. And this is just the equation that the problem gave you. Usually you'd have to figure out the 2 electrons by yourself. But since the problem gave it to you, I'm giving it to you because I'm not going to be mean. Right, so then we're going to calculate our moles of H2, because if you guys remember that at standard conditions, which I forgot to write down, but still the 0 degrees Celsius, why did I write a parentheses instead of a 0? Okay, anyway, at standard conditions, which is 0 degrees Celsius, 1 atm, if you guys remember, 1 mole equals 22.4 liters. So if we have 400 liters of H2 gas, so long conversion again, or short one, I guess, because we're just going to turn to moles and then continue. So then in 22.4 liters, we have 1 mole of H2, which should be equal to 17.9 moles of H2 gas. So now we can start our long conversion to figure out what current we need. So we have 17.9 moles of H2. And then we do that per every 1 mole of H2, we have 2 moles of electron as determined by this equation over here. And per 1 mole of electron, we have 1 Faraday. And per every Faraday, we have, so in this problem, okay, I forgot to mention this, but your Faraday constant, for some reason, it changes in the problems, and it's kind of annoying, but just keep track of whatever Faraday that they give you. And in this case, they said that it was 96,485 coulombs. So then we solve for our coulombs, because that's what we want to end up with, and we end up with 3.45 times 10 to the 6 coulombs. And then we have 1 hour, and we're trying to figure out the current. So if we remember, the current is our amps. So amps equals coulombs per second, but we're given 1 hour, so we have to convert 1 hour into seconds. And 1 hour is equal to 3,600 seconds. 100 seconds. And if you guys didn't know how to do that, it's just 1 times 60 times 60, because it's 60 minutes in an hour and 60 seconds in 1 minute. So then that's how long it takes for all of this to be plated. So we need to figure out the amp by doing coulombs per second. We have our coulombs, we have our seconds. So we just do 3.45 times 10 to the 6th coulombs over 3,600 seconds should give us 958 amps. And yeah, this is pretty much what I mean by this is just long conversion is all that this module is. So it really is just knowing how to get from point A to point B, like how everything's related. Like know that every Faraday is per 1 mole, and that every Faraday is 96 however thousand many coulombs, and then coulombs you can convert to amperes by just coulombs per second. So yeah, it's just knowing how everything's related, and it's really just a giant conversion. Yee.